In this section, we're going to cover some important terminologies that we should know in propositional logic. Let's say the terms are converse, contrapositive, inverse, equivalence, tautology, or contradiction. Now, the first three terms will be converse, contrapositive, and inverse. So they're the commonly seen related forms or P implies Q. So the converse or P implies Q is defined by the new compound provision, which is Q implies P. So it's just converse. Then contrapositive is going to be the negative version of P and implying Q. Then you negate Q and put it in the premise, and you're going to negate also P and bring it to the consequence. So this one is called contrapositive. The next one is the inverse. We simply start from P implies Q and we negate P and also negate Q. So these expressions are commonly used in logical operations that we'll learn later on. Then the next one that we should learn is called logical equivalence, and it is denoted by this notation. So this one is a statement. It is not a logical operation. We'll just tell that two logical compound logical proposition or compound logical expressions are going to produce the same outputs or truth tables or not. So logical equivalence is formally defined as two expressions are logically equivalent, or if they have the same truth table. So if they have the same input, they always have the same output for every combinations of the inputs. So its notation is this, and it is not a logic operator. Again, it only states the truth, but the true the two expressions are equivalent or produce the same output or not. The next one is some of the common equivalences. So if you see P implies Q, it's the same as not P or Q. And the next one is if you have P implying Q, which is equivalence, but it's contrapositive. This one is the contrapositive version of it, because if you want to prove this, you just put them into truth table and it's going to be the same. Then the next terminologies that we should learn are called tautologies and contradiction. So tautologies are the compound proposition that is always true regardless of the truth values of its components or proposition. Why do we need to study this one? Let's say if we see a compound proposition with multiple inputs and we have some logical operations on them, we need to create circuit in order to produce the output from the input. But if it is a tautology, then it is always true, and then we just drop that circuit, just replace that one with the on. That's it. Just one input on instead of the whole circuit. And the examples of this is, let's say if we see an operation like P imply P, then we do not need to perform a circuit for this, just replace that one with true. Similarly, if we see some circuit that perform operation on P or not P, then instead of creating a circuit for this, we'll just give the output as always on. Okay, so that one is a tautology. The next one is very similar. We'll have contradiction, which is a compound proposition that is always false regardless of the truth values of its components. So let's say why again, because if you see some contradiction, so instead of creating the circuit to produce the output from the input, we simply replace the circuit by the off or false bit. And an example of this is P and not P is always gonna bring false, okay, or it's gonna have contradiction. So now is a summary of this lecture. We already come to the second part of the course, and this one is we already learned some propositional logic is important for computer science because they works on logical values of variable that contain only true or false, which is similar to bits in computer, in order to perform some computation. Now, proposition is a statement that can only be true or false, and this one is similar to a bit. Then there are logic operations that work on propositions, which is similar to we need to operate on bits in order to create new knowledge. For computer, let's say, or computer need to operate on bits with true or false values in order to perform computations such as addition and so. Then different compound propositions can be equivalent. There's one simpler one form, one simpler one form that we should be selected in order to have the better design. Let's say when we design a circuit, we'll see that they may be too complicated. Then we use logical operation and find that a simpler expression or simpler form going to produce the same output. Then we should use a simpler form to design simpler circuit to be more efficient. Then we also learn tautologies and contradictions. If we have some circuit that is too complicated, but they always produce true or false, then we don't have to build the circuit anymore. Simply replace them with true or false values. And this one is the reference for today's lecture.